All right, today we're going to tackle something super important, the art and science of giving AI the right tools for the job. And we're not just making this up, we're diving straight into the Claude Certified Architect Playbook to show you how to build AI systems that are not just powerful, but actually reliable and, smart. Let's get into it. So have you ever seen this? You've got this incredibly powerful model. You give it a task that you know it should be able to crush, and it just whiffs. It picks the wrong tool, completely misunderstands what you want, or gets stuck in some weird loop. It is so frustrating, right? Well, here's the thing. What if the problem isn't the AI's intelligence at all, but the quality of the tools in its toolbox? The big idea we're going to unpack today is that amazing AI performance doesn't just come from a great model. It absolutely hinges on thoughtful, precise, and really well-designed tools. Okay, so here's our game plan for this builder's journey. First, we're going to get our hands dirty and craft one single perfect tool. Then we'll zoom out and figure out how to orchestrate the entire system. And finally, we'll master the essential built-in toolkit that every single developer needs to know. All right, let's start small, down at the micro level. We're focusing on how to design one perfect tool that an AI can understand and use reliably every single time. It's all about making things crystal clear and planning for what happens when they inevitably go wrong. That's the graceful failure part. I mean, just look at the night and day difference here. On the left, analyze document. What does that even mean? It's so vague, the AI has to guess. But on the right, extract web results is perfectly clear. It says what it does, what it needs, HTML, and even points to another tool for a different job. That's the level of clarity we're aiming for. You should really think of a tool description as a little user manual, but it's written specifically for the AI. It gets rid of any guesswork. By telling it what inputs to expect, what its limits are, and what other tools exist, you're not just describing a function. You're teaching the model how to make smart choices on its own. This right here, this is something you should probably write on a sticky note and put on your monitor. Your goal isn't just to say what a tool does. It's to make its purpose so unique and distinct that the model can't possibly confuse it with anything else. Ambiguity is the absolute enemy of reliable AI. Okay, so a great description is one thing, but even the best tool in the world is going to fail sometimes. The network could drop, an API could be down, you know how it is. So let's talk about the other crucial half of this. Planning for those failures was something called structured error responses. So instead of the tool just, throwing its hands up and saying, nope, failed, a structured response gives the AI critical information. It tells it why it failed. Was it a temporary glitch or a permanent problem? This is the information that lets an agent recover intelligently instead of just giving up. And this is where a tiny little flag is retryable becomes your best friend. If an error comes back and it's marked as not retryable, say for a permissions issue, the agent knows not to waste its time trying again and again. It can immediately try something else. You're literally building resilience right into your tools, DNA. Okay, so we've got our individual tools looking sharp. Now let's zoom out. How do we organize the entire workshop? This part is all about managing that complete tool system so it works like a well-oiled machine. Now, this one might surprise you. You think, hey, more tools means a more powerful AI, right? But it turns out that's not the case. Giving an agent like 20 tools doesn't actually make it smarter. It just makes its decision-making way more complicated and seriously increases the odds it's going to pick the wrong one. So the big takeaway here is all about scoped access. You want to give each agent a small, carefully chosen set of tools that are super relevant to its specific job. A research agent gets research tools. A coding agent gets coding tools. It just keeps things simple and prevents a whole lot of confusion. Think of this as your director's chair. ToolChoice gives you some serious control over the AI's workflow. You can force a specific tool to run first, like get user info, or you can set it to any to make sure the model uses some tool instead of just trying to give a chatty response. It's incredibly powerful. Okay, so how do we actually connect all these awesome tools to the AI? That's where the integration layer comes in. We use something called the Model Context Protocol, or MCP. The simplest way to think about it is as the bridge that lets your custom tools talk directly with the Claude model. And you basically have two ways to set this up. For the rock-solid tools that your whole team relies on, you define them at the project level so everyone shares them. But for your own secret sauce, the stuff you're tinkering with, you can set those up at the user level. It keeps your experiments separate from the main production stuff, which is just smart. Every great builder has to know their standard toolkit inside and out. Now that we get how to design and manage our tools, Let's do a quick rapid-fire guide to the essential built-in tools Claude gives you for working with a codebase. First up is glob. The easiest way to think about it is like a searchlight for file names. When you need to find a bunch of files based on a pattern, like, hey, find all the TypeScript test files everywhere in this project, glob is the tool you reach for. And then you've got grep, which is the perfect partner to glob. If glob finds files by their name, grep searches for what's inside those files. So if you need to find every single place a certain function is being called in your entire code base, that is 100% a job for grep. And finally, your basic file operations. Now, edit is great for small specific changes, but, and here's the pro tip you really need to remember, edit can fail if the bit of text it's looking for isn't unique. The much more reliable, safe fallback is to just read the whole file, let the model change it, and then write the whole thing back. It's just a safer bet. And this is where it all comes together beautifully. You see how you can use these tools together to understand a complex code base step by step. Instead of trying to read every single file at once and just blowing out your context window, you use glob and grep to explore and pinpoint what's important, and then you use read to dive in for the details. It's way more efficient. So if you take one thing away from all of this, let it be this. Building truly powerful AI agents is about so much more than just prompting. The reliability, the efficiency, the actual intelligence of your system, it's a direct reflection of how much thought you put into designing its tools. It is a massive force multiplier. So I'm going to leave you with a little challenge. Go look at one of your own projects right now. Find one tool with a vague description. Find one that just returns a useless error message. I promise you, applying these ideas, even just one small tweak to a description or an error response can make a huge difference in how well your AI performs. Give it a shot. Thanks for watching.